Short notes on construction materials. In this video, we'll be covering about timber. Timber is nothing but wood and it is used for building and engineering purposes. Timbers are generally classified as exogenous trees and endogenous trees. It's nothing but exo means out and indo means in. This is a general statement we all know. And exogenous trees means trees that grow outward. Endogenous means it grows inward. And distinct consecutive annular ring in horizontal direction. Here fibrous mass in longitudinal sections are present in endogenous trees. And this exogenous is classified into soft wood and hard wood. Soft woods are nothing but chir, fir, pine, deodar, etc. And hard wood are oak, sack, teak, and mahogany. All these types are hardwood, and they have major engineering applications are covered for both soft and hardwood. And when it comes to endogenous, it is nothing but the bamboo and canes and the palms. It has only limited engineering applications. Moving on to the structure of a tree, and this is the cross section of structure of a tree, how it looks. So the first thing we'll be looking at is the center part. Center part is nothing but the core, that is the pith. You call the center part as the pith, and followed by pith we have our heartwood, that is the inner part, and followed by heartwood we have the sapwood. Is nothing but the outwards of the heartwood. And then we have the followed by the sapwood we have another layer called cambium layer. This white color layer is your cambium layer, and this black line is your inner bark. It provides cover to your cambium layer, and the last exterior one is your outer bark, that is the protective layer. And in between you have some rays. Those are nothing but the thin radial fibers or the medullary rays. So this is the different parts of the cross section of a tree. Sapwood is nothing but the area between the hardwood and the cambium layer. This is the sapwood area between the hardwood. This is the hardwood. From here till this is the sapwood. And cambium layer is a thin layer between the sapwood and the, so from the sapwood to the inner bark there is a white layer. That layer is your thin layer called cambium layer. Next is defects in timber. So there are different types of defects. Those defects are due to conversion or due to fungi attack, due to insects or natural forces. So there are different classifications of defects. So first defect we'll be seeing due to conversion. So the first one is chip mark. It's nothing but the marks made by chips. When you chip an wood, it will some chip marks will be visible. Next is diagonal grains. That is due to improper sawing. You're going to saw, you're going to cut it. When you're cutting it in improper manner, you'll be having diagonal grains. Next is torn grains. Those are small depression that is found when you're sawing it. Next is vein. Those are nothing but the defects observed due to the pressure applied. Next is a second category is due to fungi attack. Here the moisture content is greater than 20%. So when it is wet, what happens? There will be the presence of air and warmth. So there are two types of fungi attack. One is dry rot, another is wet rot. Dry rot is nothing but it converted into dry powder, and their air circulation won't be there, and unseasoned soft wood will be there. There will not be any sunlight, they will not be kept in sunlight, and it will be damp, so dampness. To prevent it, sap free timbers are used. So moving on to the wet rot, there will be grayish brown powder, alternate wet and dry conditions, and unseasoned during rain and wind, and prevented by exterior work and tar or paint application. So this is for wet rot. And next is due to insects attack. So that may be due to beetles, termites, marine boars, etc. and due to natural forces. Types of shakes. So there are different types of shakes. The first is cup shakes. So this impression is nothing but the cup shake. Next is heart shake. This is the heart shake, like in the form of a ring. And the next is star shakes. The outer thing you can see is similar to that of a flower. That's a star shakes. And this is radial shakes. From the center to the exterior, it just penetrates in the form of radials. And ring shake. Similar to this concentric circle, there is also another type of defect being observed. And this is knots. Knots is nothing but along the grain direction, there will be some, in between there will be a knot. And twisted fibers, they will be twisted along the directions. And next is requirements for good timber. The main requirements are it is uniform in color and it should be of good appearance. Only then will be preferred to buying a good timber. And regular annular rings, hard, durable and tough. And next is well seasoned timber is more preferable for engineering applications. Next is preservations. So what are the steps to preserve and what is the necessity to preserve? The first thing is it is more needed to preserve because it will increase the life and it will increase the durability. It will protect from all the fungi attacks. Next is for preservation, there is a treatment. There are different types of treatment. The major treatment is ASCU treatment. That is nothing but 6 parts of ASCU plus 100 parts of water. ASCU is nothing but it constitutes of 1 part of hydrated arsenic pentoxide and 3 parts of blue vitriol and 4 parts of potassium dichromate, and it is directly sprayed to protect from white ants. Next treatment is chemical salts. Copper sulfate, mercury chloride, zinc chloride, sodium fluoride. These are the different types of chemical salts are used. Next is coal tar. So tarring is nothing but a hot coal tar applied. So the major applications are doors, windows, rough timber works, etc. And next is creosote oil. Here distillation of tar, piles, poles and railway sleepers, for that we use this. And next is oil paints. Oil paints are generally used for about 2 to 3 coats are applied on the timber. Next is selenium paints, highly toxic. It is applied in a very hot state, so it will be hot. When it is hot itself they will be applying it. And next is charring to prevent dry rot attacks in the worms. And fire resistance of timber. So the timbers are classified as refractory timbers and non-refractory timbers. Refractory timbers are non-resinous and do not catch fire easily. Examples are sal and teak wood. Next is non-refractory. They are resinous. They are made up of resins and it tends to catch fire easily. And examples are fir, chir and deodar. And next is fire resistant methods. So what are the fire resistant methods? There are 2 different types. One is special chemicals and another one is Sir-Abel's process. So first is antipyrines, example borax solution or sodium arsenate is used. Next, second method is Sir-Abel's process. For this, sodium silicate solution is made into a paste of slaker flat lime. That is nothing but the soda silicate is used. And now we are going to season this timber. So seasoning of timber. How we are going to season it? Either by natural method or by artificial method. By natural method is nothing but we are going to stock all the timbers produced either in the horizontal direction or in the vertical direction for about 120 to 180 days. Artificial methods are either by boiling or using chemicals or giving electric shocks or electrical applications. And next is kiln method, and the last one is applying water. So these are the artificial seasoning of timber. And next method is testing of timber. The basic test, there are 5 basic tests for timber. First is specific gravity, volumetric shrinkage, compressive tension and bending test. So specific gravity, the size of the timber collected is 50 by 50 by 150 mm. So specific gravity G is equal to W by V into 100 divided by 100 plus M. Volumetric shrinkage. Volumetric shrinkage is equal to initial volume minus final volume by initial volume. Moisture content is equal to initial weight minus final weight by initial weight. And oven dry specific gravity G is equal to final weight divided by final volume. Next is compressive strength test. It is conducted perpendicular to the grain to the length, and 30 to 80 MPa at 15% moisture is generally observed. And tensile test, that's nothing but tension. When you apply tension along the parallel axis, you will be getting 80 to 190 MPa. Bending test, also known as flexure test. We have previously seen this type in the concrete examination, where it gives about 40 to 100 MPa. And stress versus strain curve for the timber. And the first one is the compressive, and the middle graph is nothing but the flexure, and the extended version with the dotted line is the tension. And industrial timbers, there are different types of industrial timbers available. They are available in veneers, nothing but the thin sheets, or the plywoods, fiber boards, impreg timber or compreg timbers.